Hello everyone and welcome to a very special Motorsport Hall of Fame Awards podcast. I'm Ed Foster and I'm joined by Editor-at-Large Simon Aaron and Andy Cowell from Mercedes HPP. Now, every year at Motorsport we have a Hall of Fame and we induct great racing names into it, the likes of Mario Andretti, Michael Schumacher, Tazio Nuvolari, Valentino Rossi. But this year we had three categories for you to vote on: Formula One, sports cars, and an inspiration award. To discover the winners of these, do please go to the website, which is motorsportmagazine.com. This year, we've also awarded a very special prize that's been voted for by the Motorsport team. It's given to a person or a team that has made an indelible mark on motor racing and who may not have got the recognition that they deserve. Our magazine and website prides itself on bringing you the stories behind the headlines. So it gives me great pleasure to present this award, the Motorsports Hall of Fame Editor's Choice Award, to Andy Cowell on behalf of the Mercedes AMG HPP team. A massive congratulations.
Thank you very much. It's a great honour, and it's great to receive this on behalf of everybody here at Mercedes AMG HPP.
I hope you can find space on your shelves, because coming into this Brixworth, I would call it an office. It's not. It's actually a sort of a town. The walls are lined with trophies, such has been the last 6 years. So we'll come on to that, and we're going to talk a little bit about your past. We've got some readers' questions. But before we go anywhere, I just wanted to play you a message from Valtteri on what he said about HPP.
So working with HPP, obviously, it's a very close relationship between Brackley and Brixworth, and we are one team. We don't have just one factory, we have two factories, and I think the communication always between those two factories has been excellent. We're always pushing forward, as a one team together. So I think the communication has been one of the key things with problem solving and finding the gains in performance, and finding the faults and fixing them has been a key.
So you're going to be going to the pit straight, and I think you could do one or two donuts there. So just get them in nice and early. You're going to be pulling up at the start-finish line.
I also want to say a big thank you to everyone at HPP. Just what a fantastic job. I'm so grateful the engine did all these races, no faults. Big thank you, guys. Keep pushing.
So we heard there from Valtteri and from Lewis. Valtteri talking about the collaboration between here and Brackley, and then Lewis complimenting you on the reliability. And you mentioned just before we started recording, he completed every single lap of racing this year.
Yeah, getting a car to be reliable is a huge challenge, both on the chassis side and on the power unit side. And this year, Lewis has managed to do every single race lap, which is all credit to him and everybody that puts the chassis together and everybody that's put the power unit together. So it was a bit of a nerve-wracking last race, to be honest, because we'd got a clean slate up to that point. And everybody that was working on his car knew that the record was intact at that point, and it was a big cheer at the end as he crossed the line, and then we watched him do the donuts, and you look at the temperature. Yeah, with permission. It had been mentioned in the briefing in the morning, so he knew what to do. Yeah, just nail it. It was great to see it drive in to its position on the grid and turn off. Season done.
Amongst the wider world, when the hybrid Formula One era began, there was a lot of scepticism that there were going to be 4 cars finishing the first race and all the rest of it. But I know that it's exceptional for Lewis to have finished every racing lap this season. But generally, since the start of 2014, you've had, it's not been perfect, of course, but I mean, your reliability record since then has been pretty exceptional, hasn't it?
It's not been perfect. There's been some hiccups. Certainly, Lewis in 2016 had the rougher end of it compared with this year. But we all know here. People have been working here in Brixworth for over 3 decades, trying to make the most powerful and the most reliable engine, and then hybrid system when KERS came in, and now power unit. And we all know that you need to be fast, but you've got to finish, because you don't get any points until you finish. And it's both. Finishing 11th every single race is a little bit boring. Starting the race in first place, but only doing half the race is also boring. You've got to get both together, and that's what everybody here works so hard on. Is the performance edge, but also the reliability, so that the drivers can trust the power unit, that they're not constantly apprehensive about the power unit, and at the circuit we can concentrate more on chassis setup rather than having to dial the power unit in.
On the subject of reliability, you obviously have the sort of the party mode for qualifying. You can turn it up. How over a season, how long a time can you is it 10% of the time out of a power unit's life that you can use that mode, or is it not as easy to define as that?
It's not so easy to define. We have a qualifying mode, and we have a regular race mode, and then we have a race plus. Race plus came after race because it was a little bit more than race. And also we have a race save mode, which Lewis is exceptionally good at turning into. As soon as he knows his race is in a stable position, he's the one that turns into the race save mode, and he's brilliant at just looking after the hardware. Often gives us a few heart attacks. We still think the race is on, and he's turning it down. The qualifying mode available for every important lap in qualifying, the start of the race, and then some key points. But then what we've ended up doing is expanding our race plus mode such that we use the qualifying aspect at the start of the straight where it's the most important. So these modes, they've evolved ever since 2014. 2014 was a nerve-wracking time where we didn't know whether we would be able to complete the first race, let alone the championship. We went track testing, super nervous. We'd got 8 cars that we were powering at that point, so that volume as well as the new challenge. And the modes were very simple then, and they've evolved over time. And it's always the case that if a power unit is surviving well with the current duty cycle, the current level of mode allowance, the next power unit prove out, you say, well, can we stick another 20 kilometres of qualifying mode per event into the prove out? And then you let the engine tell you, you run enough data samples in the factory, mimicking the car as best as possible. You look at the results, you put a safety margin on, and you go racing with that allowance.
From an engineering perspective, has the hybrid era been the most kind of stressful because it's a relatively, the 2.4 V8s were all right, they were new when they first came out, but the technology was the same as what had gone before, just in a different volume. But this was a completely different thing. So has that sort of been a more challenging, more stressful environment?
I think anything that's new is challenging and stressful, but equally is exciting. I think all engineers like doing new things. They like working on new technologies. And I think the extra bonus we've had out of this new set of regulations is that there is a fuel flow limit. So there's an energy flow limit, and it's the group of engineers that can create the power unit that gives you the most useful energy to propel the car. And from an engineer, there's a certain happiness about working on a machine that's converting more energy in a useful way. But the challenge of 2 high-power, high-speed electric machines, 2 inverters to go with it, a big battery pack to manage both of those, the control to look after not just the fueling and the spark timing in the engine and the variable inlet, but also the scheduling of the MGUK and the H and variable inlet systems on the compressor. Managing all of that together was a significant challenge over where we were in 2013. But the group of people here, the group of people that are sat behind me and beneath me in this building, they love a challenge, and they love that challenge of taking on new things, for not starting projects knowing that they'll hit the targets. They like stretch targets, both technically and timing wise.
Lucky that.
And that's racing, isn't it? Or any competitive company, any successful competitive company. And we're also fortunate that the history of this company is such that we've got a large amount of vertical integration. So for the engineers that are coming up with concepts, the guys in the performance area, the manufacturing hall is just 100 meters away, and so the manufacturing engineers can sit and have lunch with the design engineers. They can have regular meetings, and so the ideas come from around the whole factory. They happen to be released by a product engineer releasing drawings and CAD models, but those ideas are captured around the business and wrapped into that drawing, and then people miraculously turn it into reality of a component. Gets built, it gets tested, and we learn. And we have an attitude of every experiment teaches you something as long as you get a conclusion. Whether it makes the car go quicker or slower, as long as you get a conclusion, it's a good experiment to do. In all development, if it doesn't make the car quicker, then you turn around and go the other way, and invariably that direction then makes the car go quicker. There's no real magic. You try things and you learn, and then you move forward.
At what stage during the 2014 season did you begin to believe that we have cracked this?
2014 was one of those emotionally strange years. The lead in 2013 was exceptionally intense for everybody in this business. Partway through 2013, we asked everybody to work more hours because we couldn't see how any of the 8 cars would finish in Melbourne, and so we painted this horrible image of all 8 cars being parked by the side of the track, and us and the Mercedes brand being humiliated. And everybody dug deep and worked some incredible hours, and with some amazing ingenuity to solve issues right down to the last moment. As the very first engine that we passed off for Melbourne blew up. The whole gear drive exploded. Yeah, so the very first engine that we passed off blew up, crank gear came off. And there was a group of us here for 24 hours trying to work out what to do with the next engine. Clearly you couldn't pass off the next engine because a gear drive destroys lots of hardware that we just didn't have replacements for. And so we went to Melbourne really not knowing how we were going to get on. So seeing lots of cars up at the front, but then having the heartbreaking moment of Lewis at the front but a misfire simply because a rubber tube had split and the spark had jumped across. Something as trivial as a rubber tube splitting and causing a DNF. The emotions of being on the podium with the constructors trophy because Nico won. We got a 1, 2, 3, and then we just won lots and lots of races, and our reliability was shocking, but it wasn't exposed on the track. So that safety margin, was about right. The torment of then going to Canada and the KERS module overheated. Canada is one of the toughest races for the KERS module in terms of K duty. And so then suffering a DNF. Breakfast on the Monday morning when I got home, and my young son said, "Daddy, why did you let Red Bull win?"
Tell you what, there's no one more cutting, I don't think, than your son saying that.
And I wasn't the only one experiencing that in the factory. Yeah, everybody in the factory experienced that.
Well, your son was going around talking to all of them.
No, I don't think it's that close-knit. But, everybody was like, "Oh, no, what we're doing?" And in the airport in Montreal on the way back, I bumped into Pat Fry, who I knew from working with him at McLaren. And he said, "Thank goodness you didn't win, because otherwise you stood a chance of winning every single race this year and then beating the McLaren 15 out of 16, which he was associated with." So 14 was a roller coaster of emotions all the way to the last race, where it was double points. I remember it going down to the last race with Lewis and Nico. We had a problem with the KERS cooling pump, And Nico saying, please let me finish the race. We wanted to DNF the car, but he said, no, please let me finish. So all the way from, you know, the first race engine going to Melbourne blowing up to the last few laps of Melbourne was full of emotion. And at the time, all I was experiencing was the painful stuff. And you don't get any time to enjoy the happy stuff. It's only at the end of the year when you go and, you know, with Toto to go and collect a constructor's trophy, where you go, wow, we did it. And I love seeing the engine down in reception, the 2014 championship winning engine, because you see all the patches that grew on the cooling of the ERS module through the year when we let Red Bull win.
I want to come back to the hybrid era in a second, but just to kind of rewind it a little bit, you sort of started in motorsport by helping your dad sprint and hill climb. You've come a very sort of long way since then, and I think when you went to Cosworth, you did the graduate scheme, and you went around every single department, but basically finished and then stayed in the engine department. Has it always been engines or now power units, or was it the engineering of motorsport that excited you in general?
It's the engineering of motorsport in general that excites me. It's creating things. And I think, like many of the people here, you know, there are significant people around you that engineering rubs off onto you. For me, it was, you know, being in the garage helping my dad build sprint and hill climb cars, and that's what we did at the weekend, and that's what I ended up doing when I was old enough, and my dad was kind enough to share his car with me, and I broke it a few times as well. Sorry, Dad. But you get education can be not particularly inspiring, and so it's good to have something that inspires you. I think today things like Formula Student do a great job for inspiring children on what you can do with maths and physics, how you can apply it. I think the UK motorsport industry provides a great opportunity for engineers going through education, going through university. But then I think I'm like lots of the people here. I've enjoyed a good graduate scheme. We run the same style of graduate scheme here. So we take lots of graduates on, we take lots of apprentices on, and we want them to move around so that they get to experience lots of different areas of the business, find the bit of the business that really excites you, you know, puts a fire in your belly, matches up with your skills, matches up with the needs of the business, and then your career moves on. It's a fun industry. I class myself as super lucky, to be honest. I come here and it's my hobby.
What were you and your dad hill climbing, and did you experiment much with it?
I knew that Simon really would want to know about the sort of the niche details.
There might be an MG midget story or something.
It wasn't. So the very first sprint and hill climb car my father put together was a Terrapin. So the Alan Staniforth high-speed, low-cost book and plans with a 998 Cooper engine in the back, which was a great experience, you know, when you've got father building a car like that in the garage from nothing. And then moved on to Jedi single-seaters with motorbike engines in significantly better power-to-weight ratio. And I've still got a Jedi Mark V, the only Mark V sat in my garage, but it's been sat there for the last 8 years.
But I mean, as you were sort of just starting out, did you tinker around much, just out of just pure experimentation with your inner engineer, or did your dad let you?
No, he very definitely let me, and that would probably cause some of the bad runs, some of the failed runs, and certainly, you know, university holidays and so on. I'd be in the garage tinkering on my own, and he'd come in and go, "What have you done?" but no, it's a fun way of learning, isn't it? You know, doing motorsport yourself, where you have an idea, you put it together, and you go racing, and you have success or failure. It's a good way of learning.
Fast forwarding to 2009, it was the debut of KERS, which you were heading up the project for. How how daunting was it? Because you've obviously been involved in engines for many, many years before the energy recovery systems came along. Did you, when you first heard about the rule change and the KERS, did you go and talk to any other industries? Was there anyone you could talk to, or was it literally a case of kind of trial and error to start with?
The regulations came out the tail end of 2006, or the clarity was there, and so from 2007, Ola Kalenius was the managing director here at that time, and he made the decision that HPP rather than McLaren should do the KERS system. He could clearly see it fitted with the powertrain rather than the chassis, and we used several consultants and industry partners to help us learn. And we investigated flywheels with CVTs, electric machines with either lithium-ion or ultracapacitors for storage. And we were fortunate that we took all of those to demonstrators so that you could really learn about the technology and doing that testing here. So, testing a flywheel in CVT here, testing battery test facilities were put in place, and motor test facilities, and that was Ola's vision that electric machines, high power electric machines connected to the engine was the way forward for Mercedes and for Daimler, and it would be great for HPP to start embedding that technology here. For me and lots of the engineers that had just worked on high speed naturally aspirated engines, it's new and it's exciting, and it's a bit frightening, and there's stuff to learn about with high voltage and creepage and clearance and so on, but it's you go back to your O-level physics, your A-level physics.
Yes, you got it to go back on. I don't.
And the degree I did was the first 2 years was common coursework between mechanical engineering, electrical, civil engineering. And so I haven't yet used the bridge design theory that I was taught at the time, but the electrical engineering, it was very interesting, and there's to apply that in KERS. And electrical flow is just the same as liquid flow down a pipe in terms of the way you think about it and the way you look after it. And we were very lucky that we could attract some really, really good electrical and electronic engineers, and they've done a superb job here in terms of embedding the understanding, putting the Lego bricks together, as they refer to it, of the control circuitry and so on, and that's just grown and grown, and that decision by Ola right back in 2007 is absolutely what helped us perform well in 2014, because KERS was sort of a practice for ERS, and having it embedded here meant that it wasn't so daunting, and the control architecture could all be managed here. So the controls group really were looking after every single bit of the power unit.
Are there limits on dyno testing, electrical testing, or in Formula One at the moment? Because obviously Formula One's so restricted in many ways, or can you literally have an engine on a dyno 24/7?
There are no restrictions at the moment. For 2021, there will be dyno restrictions on V6 running and full ERS system running. So over the next 12-13 months, we'll adapt to that. We'll ramp down to those numbers. And I think that's it's analogous to what's been done in the wind tunnel world. And I think it makes you think before you do, and I think that's a healthy thing for all of us, especially creative engineers, where we often tend to not think thoroughly enough. We don't do all the what ifs. So we're all looking forward to that. We know we'll have to change a little bit, but we think it'll be healthier.
Now, we've got lots of readers' questions, so I really must actually read some out. I've been known in the past for getting so involved with the conversation I then forget to ask them and get told off. There's the one here talking about the similar kind of thing from Paul via Twitter. asking how confident you are in terms of getting a handle on the new regulations, because there were rumours that the MGU-H wasn't going to be used, but I think it is now. So the new regulations from your side are pretty much the same. Is that a fair comment?
Largely the same. So progressively we'll do more races, but I hope we stick with the same number of engines and ERS systems. So stick with the same 3 engines, 2 ERS systems. And then for 2021, the fuel changes. So currently there's about 5% bio content in the fuel, but the type of bio isn't regulated. For 2021, it'll be 10% bio, but it's bioethanol, and it must come from sustainable sources, so not from food stock, etc. And then the FIA are keen for that fuel regulation to grow and grow and grow, so ultimately we end up with 100% net zero fuel. The time frame for that, we're working that out at the moment. We need to be careful that we don't change the fuel, which then demands a drastic change on the power unit. We're trying to introduce these things in a progressive, considered manner, so that all the budgets are looked after, as well as the competitive aspect of the sport.
I was going to ask fuel. Can you just give sort of readers and me, who perhaps is not so expert on, the nuances of fuel? Pump fuel for a road car is very, very different to in some respects, to what you put into a Formula One car. But in many respects, it's actually very similar. But the Petronas and the fuel suppliers in Formula One are doing almost as much development work in terms of what they're putting into your engine. Could you just give us an insight into how different is it, and how much work is going on just on fuel alone, forgetting, the whole power unit?
Yeah, I mean, the Formula One regulations are formulated around it being an unleaded gasoline, just the same as you'd use in a road car. But as with everything in Formula One, we optimise within the regulations to suit the other components that are in our car. So the fuel is optimised to go with the power unit, and the power unit is optimised to go in the car in terms of heat rejection and size and volume. So we're fortunate we've had the relationship with Petronas since 2010, and so the relationship was in place before the new regulations came in for the V6 turbo engine. Turbocharged engine, very high boost level, and you need to be the master of knock. You need to avoid knock inside the engine so that the combustion is controlled. Having a great fuel partner, as Petronas are, really helps you develop a combustion system with the fuel to optimize the heat release that then helps generate useful work rather than unuseful work. So it's a case of every single aspect of the fuel regulations. We use simulation and then experimentation on both our single-cylinder engine and on our multi-cylinder engine, just to optimize the geometry of the engine with the chemical properties of the fuel.
Is it certainly towards the end of the 2.4 V8 era, when there was a development freeze, one of the ways you could find extra power was more efficient, more combustible fuels? Is that sort of power race still going on with the fuel companies, or is it less so now?
The power race is still going on with the fuel companies, fuel and the lubricants as well. At the moment, there are no performance freezes in the power unit world, but we've just completed our 6th championship, and so with 18 months of development before we went racing and 6 years, it's a long time for the engineers to optimize, and so the gains end up smaller, but you end up looking in more areas. You start looking in areas where you assumed there wouldn't be a gain, and often because you've not gone hunting there before, you do find reasonable sized gains. So every update, the power unit gets better in terms of performance and reliability. And you know, Petronas help us with the reliability. The fuel can help you with reliability. If the combustion is more controlled, the peak cylinder pressures can be reduced for the same amount of power generation. And it's those peak cylinder pressures that try and lift the cylinder head off the crankcase, which has all sorts of bad side effects.
I think you've actually answered Pratik's question here about talking about are there any more gains to be made in the hybrid era. You were just talking about that. There's one from Chris here, which is quite interesting. He says sound or lack thereof. How do you feel? Do you feel sympathy for the fans given the muted notes of the current PUs?
I think in 2014, none of our engines were particularly well tuned. We were running a lightweight exhaust system, and so not equal length primaries. I think now everybody's got a very well tuned engine. All the lengths are a nice equal size, and I think the sound is pleasant. The volume isn't high, but it's still pretty noisy. And I think now all the other supporting championships have got turbocharged engines, and you go to a Formula One race and everybody's running a turbocharged engine, and they all sound fairly similar. And I think we're seeing more families go to the circuit. I think previously with the screaming V8s and the screaming V10s, there's no way a child would go anywhere near the circuit. You wouldn't inflict that on your child. And there's lots of us that have got damaged hearing from working in the industry in that time, and so therefore I think it's a good progression.
There's one here from Paul that I wanted to ask anyway. Actually, he's asking about the technologies that you start in racing that go into road cars. It's more and more a hot topic. I mean, I know Formula One has been carbon neutral since 2000, I think. But obviously there's a lot of focus on, well, you guys are driving around in circles, burning fuel. How much use is Formula One in the everyday world?
I think I understand the criticism fully. You know, we start and finish in the same place, but it's a development platform. HPP has always had the head of R&D as its chairman. Two of our board members are from the engineering side of Mercedes-Benz research and development. Currently one of them's responsible for internal combustion engine development going forward. The other one's responsible for e-drive going forward. And so the chairman and those two guys learn about everything that's going on here, which benefits the knowledge that's going into the road car world of Mercedes-Benz, but also benefits us with our racing programs. There's several times when we've had reliability issues where we've phoned a friend in Stuttgart and said, we can't understand this at the moment, can you send a couple of experts over? And they do solve the problem very swiftly for us. So that technology transfer flow happens all the time, and there are, you know, lightweighting, reduced friction, improved combustion efficiency. All of those aspects are flowing into the road car world. Efficient electric machines, efficient inverters. So the technology in our inverter is of great interest in the road car world. And high voltage batteries. In Formula One, we're allowed to run up to 1,000 volts. Ever since 2009, we've run a 800 volt battery. The higher the voltage, the lower the current for the same power level, and it's the current that kills you in terms of the losses. So that learning is being transferred across into the road car world, more so on the hybrid side now and the electric drive side than on the internal combustion engine side. But I think it's a lot of it is the methods and the can-do attitude. I think sometimes it's good to be able to just, you know, some guys come from Stuttgart and come here and spend a day looking around, and there's a sudden, oh yeah, why don't we do it like that? or just looking at things spurs an idea. So I think having that close relationship because of the board membership and the open access, that just helps with ideas and methods and attitude, both directions. You know, we've learnt so much from having that connection to Stuttgart's R&D facility.
Talking about sort of the cleanliness, as it were, your 2017 power unit achieved a conversion efficiency of more than 50% on the dyno, which was the most efficient racing engine ever made. Just tell me exactly what that means. I'm not joking. I'm not an engineer. I have to ask these questions.
You haven't even got a physics O level, have you?
Well, no, I haven't.
So if you've got fuel, unleaded fuel, if you burn that fuel, then the total amount of heat release sets your 100% mark. Yeah. So all that energy that comes out from the combustion, that sets your 100% mark. Now, we convert that bonfire, over 50% of that bonfire, we convert into useful work that will propel the car along. The other 50%, that goes to the atmosphere, either through the tailpipe or through the radiators. Now, a typical road car, it's only about 30%. So for that normal 100% bonfire, only 30% will propel the car along. 70% goes to the atmosphere.
I tried to think what my 1991 Fiat Panda's like. No wonder it's so slow. That's amazing.
So the V8 engines in 2013, it was about 29% of the energy from the bonfire went to pushing the car along.
With such a small percentage or such a big percentage loss, why? I mean, obviously it might be a stupid question, but why was there not more focus on this efficiency before now? Because, you know, for all the work that goes into creating more and more power and 1,000 brake horsepower, 1,500 in qualifying mode, if they just sidelined a bit of that effort into trying to make things more thermally efficient, then that would have worked. I guess you're about to say this is a very stupid question.
No, it's not a stupid question at all. I mean, the FIA had the thought of going to a fuel flow rate and a fixed quantity of fuel for the race as early as sort of 2007, 2008, and they envisaged going racing with that style of regulation in 2011. We wrote regulations for 2013 introduction, but that was on a 4-cylinder engine, which was deemed not fashionable enough, and so we changed to a V6. All the other numbers stayed the same, and delayed to 2014. So the FIA always had this idea of introducing a fuel flow rate, an energy flow rate formula, and it was a big change, wasn't it, for 14? But I think it is very well established now as it is the correct way to go. We should keep developing it. With time, we should make sure that the fuel is as close to net CO2 as possible. So we're not taking carbon that's been captured millions of years ago out of the planet. We're taking carbon dioxide out of the atmosphere and converting that into a liquid fuel, a liquid gasoline. And the more we can do to use the waste energy on the car. You know, a turbocharger is taking waste energy out of the exhaust stream. Instead of the hot gases going straight out into the atmosphere, you're taking that energy to drive a turbine wheel. The MG UK is taking the kinetic energy, so the mass and the velocity of the car, that chunk of energy, and putting it in the battery to use again. And the more we can do that, and when you look on in the road car world, brakes should disappear. We should all trust electric machines. Yeah.
You clearly haven't owned a Fiat.
No.
There we go. Right, let's get some more readers' questions. We have got loads of them. There's one here from Hamza, who's asking whether or not you can match Ferrari's power unit performance in 2020. I wanted to ask about Ferrari this year because you know, I think it was Mark Hughes who did a very interesting piece on Motorsport's website about the advantage that dominant teams have had in Formula One throughout the years. So Williams, the Mansell PK era, they were roughly 1.5 seconds, I think, a lap faster than everyone else. But you guys have been 0.3, and actually it hasn't been complete dominance. But it feels to me this year there's certainly Ferrari has definitely caught up, if not overtaken a bit. Is that a very difficult thing to watch when you've been so dominant since 2014?
Yes, we our primary aim is to make the fastest race car, but all the areas that go to make up a fast race car, whether it's the power unit, whether it's the aerodynamicists, whether it's the vehicle dynamics, the tyre engineers, whether it's the pit stop crew, whether it's the tactician, we all want to win our own little championship against the others. Ferrari did a stunning job of reacting in 2014. So they reacted very early in terms of the fact they were a long way down, and they've been chasing hard with huge determination. This year there have been races where we've beaten them quite convincingly, and vice versa. Every time you're beaten, it hurts. And if it doesn't hurt, you should probably retire if you're in a competitive industry. So yeah, it hurts like hell. It's always tough being in the factory at the start of the week. We do a race debrief every Monday after a Grand Prix. We do it at 11:30 with half a glass of champagne if we've won, and wear our green race winner T-shirts, or we do it at 5 o'clock if we've not won. And those 5 o'clock ones are painful and they hurt. But we say what we've seen, we say what the data says, and we say what we're working on to close that gap or extend our advantage if we're fortunate to be in that position. And every week we write a team brief note to everybody in the business to say how it's going in detail. And I don't pull any punches in that.
Okay, we got another question here. I think from Hosni is his name. His name is in Arabic to the left, but I'm afraid my Arabic is not actually that good. He's saying, congratulations, Mr. Cowell, for the great work. He obviously doesn't know about the award, so he's just saying in general. He said, I heard that Mercedes PU is not number one anymore. If it is true, is it linked to the architecture you chose at the beginning, which has fewer possibilities of development?
I think in terms of out-and-out qualifying performance, then Ferrari this year have shown that their car is better. But you don't get points on a Saturday. You get points on a Sunday in terms of finishing the race. And we work very closely with the team at Brackley to make sure that the power unit contributes to the overall car performance. I don't think the architecture is holding us back. Every year we have a very open look at the way the power unit should be laid out. A lot of it is determined by the regulations in terms of where you can put the turbocharger. Either it's towards the front, sort of split across the crankcase like we have it, or in the back in the transmission. Typically, from an aerodynamic perspective, you want to follow the shadow of the driver's helmet and the crash structures as around that. So I think if the Ferrari qualifying performance is all down to crank power, then we just need to work harder and we just need to find more crank power for those single laps in qualifying. But what we mustn't do is destroy the performance of the car on race day. I think the aerodynamicists and the vehicle dynamics guys have done a great job of making sure that the car is very kind to its tyres and can stretch well and can be raced hard throughout the race. And the total car package in terms of reliability, I think, is a key aspect as well as the tactics of the race and the management of the drivers.
From an engineering perspective, are you slightly disappointed that the regulations in 2021 are so similar? Because you were saying earlier in the conversation how exciting it is to have this enormous challenge on your hands when you first came into the hybrid era?
As an engineer, I think as an engineer that likes to be creative, likes new challenges, likes to be in the mire of a new challenge, and fighting his way out, then I wish there was more change. But I think Formula One is moving in absolutely the right direction. And I think the V6 and ERS power unit that we introduced in 14 is now absolutely the right power unit. And I think it's good that the four manufacturers just iterate more and more and more. We've seen, Honda are the best improvers this year. They're way ahead of Ferrari in terms of development rate. And so let's have a close battle with the same set of regulations. I'm up for that. And then let's come up with a new set of regulations for maybe 2026, which is perhaps a bit more of a step away from what we've got now.
I was going to ask you about that because in the short term, given the level of improvement Honda has shown in 2019, where do you see the bigger threat is coming from Red Bull Honda or from Ferrari?
I think they're both formidable. They've both got owners that are determined to win, not just attend. And Red Bull can make championship-winning cars. Max Verstappen is
quite
formidable. Yeah, quite a handy chap, isn't he? And Honda have got, their investment in what they're doing is huge. And their determination is huge, and that's showing on track. And you can see that there's structure and sound decision making being done. And I think that's it's going to be exciting. And I love an engineering challenge, but I enjoy the challenge on the track more. The thrill of a full race weekend and 21 races over the championship from March through to December now. If we can have 6 cars going wheel to wheel at every single race, and there's some racing incidents that end up deciding it, well, that's a cracking championship.
Now we've got about 5 minutes left, and I was going to fire some sort of quick fire questions at you. The Formula E side of things, obviously it's new. Mercedes is now involved. Have you been involved in that in any way? And what have you been doing to sort of help them with your,
So there's a team of people that formerly worked on Formula One and on the AMG 1 hypercar that are now have over the last 18 months created the powertrain that Mercedes-Benz Formula E are using. So the inverter, DC-DC converter, all the control aspect, and the electric machine and the transmission. So they've taken F1 technology, taken the road car technology, pulled it all together, and created a good package.
How niche is Formula E in terms of learning how to go quickly or build a quick car compared to Formula One? Because ultimately they're 2 single-seaters with 4 wheels. And there's similar technology in both, but it is quite a different beast to tackle, isn't it?
It's got all the same elements. Instead of 110 kilos of unleaded gasoline as an energy source, it's got a standard supply battery with a fixed amount of energy kilowatt hours that you can take out of that battery over race distance. In Formula One, you don't have to do any fuel saving at all. The 110 kilos that we've now got is super generous, so you don't need to do any energy saving. You've got 100% of what you need for a full race.
But you'll still do some energy saving because you don't obviously fuel the car.
So if you want to start light, you can do, but your consideration is typically not that you don't have enough energy. In Formula E, you've only got 70% of the energy that you'd ideally like, 70 to 75% of the energy you'd ideally like. And so for the drivers, it is a case of how best to spend that energy to finish the race as quickly as possible, but equally not let your opponent pass or to overtake your opponent. So it's there's a pot of energy. There's an abundance in F1. There's a limited resource in Formula E, and there's a lot more standard parts in Formula E. But then it's down to the operational excellence of the team and the way they react to yellows and attack zones and so on. So a little bit more strategy through the race.
I just wanted to talk briefly about the diesels at Le Mans. So obviously, from an engineering perspective, you've been sort of very much Formula One, but I suppose you must have watched that era with a lot of interest.
Yeah, I think the work that Audi did, Ulrich Boretsky did, was fascinating. The regulations in Le Mans are energy based again, with various numbers based on the fuel type that you use. And Audi seized the opportunity when the regulations were about right, and it fitted in with their road car direction of the time. Don't think we'll see any more diesels racing there.
It's been somewhat turned on its head, that fuel. I wanted to ask, what do you think has been your greatest Eureka moment in your career? That might have been when you were spannering your dad's sprint car, or it might have been something in the hybrid era, or in terms of, or an idea, not necessarily you, but your team. Has there been something specific you look back on and think, God, what a brilliant idea that was?
I think in terms of technologies, I used to work on the pneumatic system when I was at Cosworth, and there was a couple of breakthrough points there that were particularly enjoyable to be in the muck and bullets of and moving things on. And we moved the pneumatic system from running at 13,500 RPM to then getting up to 20,000 RPM. That was a fun journey to be in the muck and bullets of. For me now today, it's the thrill of seeing everybody working together. It's the organisational side. It's trying to set tough targets, but put people in roles that suit their personality and their skill set. So it's a role that they enjoy doing, and their skills are strong, and the needs of HPP and Mercedes in motorsport is there, and trying to remove all the impediments so that they can thrive. And that gives me the biggest joy now, just seeing that team of people, the individuals, and then the team of people work together. Well, that's the thrill now.
Looking back over the history of internal combustion, is there one particular engine you wish you'd designed, or are you quite happy with your CV as it stands?
I've got this fascination with the Merlin engine. There's something quite emotive, quite emotive about the Merlin. The sound, the story. There's a book called Not Much of an Engineer, which is about Sir Stanley Hooker, who was probably the first mathematician to go into Rolls-Royce and help the development of the compressor. That's probably the most enjoyable book that I've read in the last couple of decades. So that's a fascinating period of engineering history. A horrible period of time for the world in terms of what was going on, but in terms of engineering, tenacity and determination. And I think motorsport is this fast-paced laboratory. Clearly, we are not at war, but we're competing against each other, and there's a huge amount of determination to win, but to shake our opponent's hand if they win and we're second, and shake the hand, walk away, learn, and come back stronger than the next race.
Andy, we're going to have to wrap it up there because I know you're very busy, but I think at some point in the future you're going to have to get a Merlin into your hill climb car, and that can be your engineering hurdle when you're retired.
If anybody knows where there is one that's for sale, please let me know.
Great feature in motorsport. A huge congratulations to you and the team here at AMG HPP on the Editor's Choice Award. Very well deserved, and an amazing era of dominance so far, where where you haven't had a huge advantage. So congratulations to all of you. Simon, thank you so much for joining us. Thank you to Alan for recording this. We'll be back next month with another Motorsport Magazine podcast. Thank you so much for watching, and thank you so much for listening. Bye-bye.